To overview the setup of the Lab 4, we have a power supply, a triple power supply that will have 3 voltages. This is the way it should be set up when you walk in, but if not, make sure that it is in this configuration. We will have a multimeter. This will be what you're reading your voltage outputs from, and then the buckling rig itself with the knob on the top to twist, as well as a ruler at the bottom, and then a load cell, and all the electronics are embedded within this 3D printed case. There will also be a container with the blade as well as 2 fixtures, and then going into the lab you should have already cut 2 members. This is the power supply setup. The rig electronics requires 3 different voltages. You'll want to have the main voltages set to 15 each, and right now you can see that they are off, but when we're ready we will turn them on. And then also down here you can see that this knob right there, I'm trying to point to it, right there, is set to 5 volts. And then we need to look at the 4 different banana plugs and make sure they're in the right locations. So the yellow is going to be our plus 15, and the red is going to be our plus 5. The green will be our minus 15, and then we also have a ground. All of these will be labeled. Make sure they are in the right location. We also need to make sure that the ground of the power supply is connected with all of the voltage terminals such that they output the right voltages. So this needs to be in the ground here to have a plus 15 there, and it needs to be on the ground for the positive terminal here so that we result in a negative 15 voltage here. This is very important, so make sure it's set up correct before you move forward. And once it is set up, you can push the on buttons to send out the voltage. The multimeter setup is much more simple. All you have is a ground port and then a voltage out port. And then I have mine set to millivolts. And I have it zeroed at 0.5 millivolts, which is very good. And as long as the power supply is on, as you can see with those lights, when I push down on the load cell, this is the load cell, you'll see an increase in voltage. And that voltage will be converted into a force. The buckling rig setup will start with this little container. It will be full of these fixtures to hold your members, this blade that will go onto here. You will need to make sure the blade is parallel with this blade in order to match up with this groove, which will fit in there like so. The members that you will have pre-cut will require you placing into the fixtures, and I'll do that in the next bit. To prepare your members, you're going to have to install them into these fixtures, and these fixtures will fit the member onto the buckling rig. So to start, the first thing you're going to want to do is, when cutting these in the machine shop, make sure that you get these filed down and clean cut such that it can slide into the fixture without a problem. Because if it's not, then it'll stick and you won't be able to fit it in there, because this is a pretty close cut as is. So your goal when pushing it in here is to try to get it into the center of the fixture, and also try to get it flush against the back. For this, you're just going to have to push, and once you get it nice and tight in there and lined up well, then you use the thumb screw to tighten it and secure it into place. You'll have to do that for both sides. For the flat member, it's a little bit more tricky, because if you were to use the thumb screw and push it straight in, then it's going to be all the way against this back. And we really want to keep the member as centered as possible. So to do that, we use these spacers. put the spacers on each side. I use 2. Your member should be about the same, but if not, just use whatever seems to work. Slide it in, and then also, once again, try to get it in the middle of the fixture. And so it looks like I've got it in the middle, and so I'm tightening the thumb screw, and now it's nice and secure. It could be a little bit more flush, but I think for demo purpose, that is just fine. Get both sides, and then you'll be ready to install it onto the buckling rig. All right, now our member has been placed within the fixtures, and the thumb screws have been tightened. The spacers are properly done. The last thing you need to do is to insert the member within the buckling rig. So the fixtures have a groove, and the blade, they should line up. So the first thing you want to do is line up the bottom groove with the blade, and then the top one, and adjust the knob to get it secured in there. Once it's secured, you should be set. It won't move. You can wiggle it around. Now it's in there, and you want to make sure that it's not resting against any of the pieces, but that really shouldn't be a concern. So you're pretty much ready to begin. One last thing you'd want to check is your multimeter. See if there's any voltages that you want to zero out. I think that you could have a couple millivolts, 2 or 3, because as you adjust the knob, you're going to increase into hundreds of millivolts, so just a couple is not a big deal. Mine's set to 0, which is great, so we're not going to adjust that anymore. So we are all ready to move forward with the experiment. The only thing that needs to be done is this knob needs to be twisted to compress the member, and that will begin your experiment. And make sure that you get a video of the experiment. I'll show a good idea of what your camera angle should look like. It should include this and the voltage. If you are not satisfied with that 0 value, which 0.1 millivolts is very satisfying, but if not, you will want to look at your box and then go underneath it and adjust this potentiometer right there. As you can see, you'll use a little screwdriver to twist it. This little screwdriver, and you'll twist it. And by twisting it, you'll adjust the millivolts until it returns to 0. And then you'll be set. This is a good camera angle to run the experiment with. You can clearly see the voltage on the multimeter as well as the deflection on the member. Once I begin running the test, you can watch the voltage increase as well as the member deflecting. Right now you don't see much deflection, but you do see a lot of increase in voltage. And as I continue to run through the experiment, you can see that the voltage kind of levels off at this 274 millivolt region, but the deflection continues. I keep pushing through, but the voltage doesn't seem to increase. This is a good sign that the member has buckled, so that's a good point to stop. You should be calculating these voltages ahead of time with the information given in the lab doc, but I'm just going to go based on that to stop the test. Now I'll show you the member after I've removed it, and you can see that there is some curvature. It is permanently deflected. It's not a great buckle. The hollow tube has a much better way of looking at it, but this that's an example. Alright, once you're done, you'll want to take your blade off, put it in here, put your pieces back in here, take all your spacers, drop them down, put it in, drop that in there, and also you'll want to turn off the power supply. Off the power supply, you can even flip the switch if you'd like, but it's not necessary. And then you can also turn off your multimeter because we don't want to waste any battery. Leave everything plugged in for the next group because it's likely that someone's going to be going after you.